This is video 3 of topic 3 on precipitation, and we'll talk about IDF curves. For engineering design applications, we typically need to know the intensity and duration of precipitation events, as well as their frequency of occurrence. These three storm characteristics can be related to one another in either equation or graphical form. The equation is similar to ones we saw in video 2, and we can also graph several intensity duration curves, each for a different frequency or return period on the same chart. I'll show both of these in this presentation. The IDF curve equation can be developed based on number 3 from the last video. Let's assume that constant A is related to the return period as A equals kt to the n, where k is some coefficient, t is the return period in minutes, hours, years, and n is some exponent. And to complicate matters, this is different from the n you saw in the previous equations. Remember too that I is the rainfall intensity, depth per time, and t is the rainfall duration, obviously in time. Okay, so here's my intensity, my frequency, and my duration, I, d, and f. The values of the constants k, b, m, and n are determined from measured data or local experience. Now, equation 4 can be used with tabulated values, so that's one form. Note that we're using slightly different symbols here. This is because the source is different. Okay, here Tc is the event duration, and I is the rainfall intensity, and those are going to be our two variables. Okay, so this is the variable, this is the value we're trying to predict. We can tabulate those values for different return periods for a number of different counties in Texas. So this is a manual from the Texas Department of Transportation. And all you would do here is plug in the values for E, B, and D into this equation for your desired event duration, and then you can calculate the intensity. So here's an example. This is using equation 4 and the tabulated values here to find the intensity of a 24-hour, 100-year storm for Terrell County, Texas. Here's my basic equation. I is equal to B over Tc plus D to the E. I take these values from the table, plug them in. I get 2642 over some value plus 8.8 to the 0.805. The only thing I need to figure out here is what value to put in for Tc. This is going to be in minutes to give me inches per hour. It's an empirical set of equations. And so for Tc is 24 hours, that's 1440 minutes. That's what I put in. And I end up with an intensity of 7.53 inches per hour, which is a pretty high intensity. But it is a 100-year event. Now, rather than tabulating values for derivations, as I did on the previous slide, I can also just tabulate individual values for 24-hour rainfall depth for a number of different Texas counties. So here's Terrell County, 100-year event, and the values here are given in inches and millimeters. This is a slightly easier way of doing it, but the previous way is more general for different duration storms. The approach you're more likely to see in this course is the graphical approach. This approach combines in one graph a bunch of information on intensity, duration, and frequency, and when you combine them all together, you get the IDF curve. It looks like this. Here are two examples. This is Santa Fe, New Mexico. This is Baltimore, Maryland. Here's the set of return periods, so you can read 100, 50, 25, 10, 5, and 2. Here's the duration along the bottom, and here's the intensity. If you want to look up a 1-hour storm, here's my 60-minute mark with a 10-year return period. then its intensity will be just about 1 inch per hour. Okay, so that's how to use this sort of information. Notice there is a significant difference as we go from one location to another. Santa Fe has typically lower intensities than Baltimore. This is East Coast, this is fairly arid, and the storms tend to last significantly longer in Baltimore than they do in Santa Fe. Here you can see, even with a 100-year return period, we don't get to 24-hour storms. Note that this is one set of scales. This is a log-log plot. It's also possible to do an arithmetic scale, in which case you see very clearly that intensity drops off very quickly with the duration. The longer duration storms have much lower intensities than the short storms, which can have very high intensities. This is the end of video 3.